Hi Year 12s and welcome back to the continuation of this series on circular functions. I hope you've had a few days off to rest after a really big term 1. I know I've needed a break as well. As the term 1 holidays get underway, please be on the lookout for 5 videos, including this one. So we'll have 4 videos to finish off chapter 6, and then I will record a video where I go through the solutions to the test that we did in the last week of term, step by step. In this video, we'll look at how to find an equation for sine and cosine graphs. In the past, I gave you the equation and said sketch the graph. Now we're going the other way. This time we are starting at the graph and you are finding the equation. Or I should be more specific by saying we're finding an equation because there are many possible solutions and many possible equations that could be used to describe one graph, and you'll see this as we get underway. So we've got 3 examples, and here's the first one. So I've given you a bit of guidance. I've told you to look for a sine graph, and that turns out to be quite simple in this case because this graph already starts from the mean position at x equals 0, just like the original sine graph, alternating between 1 and minus 1, starting at 0. So that tells me immediately that I don't need any horizontal translations. I will need vertical and horizontal dilations, and I will need a vertical translation because the mean value is no longer 0. Putting those things together, I can write down an equation of this form. Y equals a times sine of nx plus k. Capital A will define the dilation from the x-axis, n will define the period indirectly, and it will also define the factor of dilation from the y-axis, where that factor is 1 on n rather than n. K will define the vertical translation, and k is also the mean value since the original graph of sine has a mean of 0. So let's put these things together now to figure out a, n, and k. Maybe I'll start with the period. The graph has 2 cycles. So that means the period will be half of 10, which is 5. We also know that the period is 2 pi on n, where n is this number multiplying the x term inside the sine function. So now I can say 2 pi on n equals 5, since I know that the period is 5. And rearranging for n, I get n equals 2 pi divided by 5. Next, I can write down the minimum and the maximum. The minimum value is 2. The maximum value is 10. The mean value is the average of the minimum and the maximum, which is half of 12, which is 6. And the amplitude is half of the difference between the maximum and the minimum. 10 minus 2 is 8, and half of 8 is 4. So that tells me the mean value is 6. And in this case, the amplitude is 4. And this raises immediately a choice. Do I choose a equals positive 4 or a equals negative 4? And the answer to this question is, it actually doesn't matter. As long as you take into account that if you swap the sign of a, you need to do a horizontal translation to compensate. So, for example, I could choose a equals negative 4, but then I would need to include something like this. A horizontal translation, b units to the right or left, depending on which way you wanted to do it. And that translation, b, would have many possible values since the graph is periodic. Obviously, this complicates matters. And since this is a positive sine graph, where it's increasing at x equals 0, there is no need for us to introduce a reflection. And most people prefer to keep the number multiplying the sign positive. So we'll stick with that strategy. We will keep capital A as positive, and we will not require a horizontal translation here. And so hence, the equation of this graph is 4 times sine 2 pi on 5 times x plus 6. You can see that if you take the time to write down the period and the amplitude, this becomes quite straightforward. And of course, 6 is halfway between 2 and 10. Okay, so if you're happy with that, we'll do another example. This example is a bit more difficult. So I want to spend a little bit of time on this. The hard part about this question is that there's actually no graph given. So normally what we would do is we would look for turning points to determine how far the translation has gone. But I haven't given you the graph. So we'll have to write down an equation and solve this algebraically. In the absence of any further information, we'll need to assume the most general form of a trigonometric graph, where we have a dilation from the x-axis by factor a dilation by a factor of 1 on n from the y-axis, followed by translations b to the right and k to the up. Of course, allowing for the possibility that translations might be in the negative direction as well. So this is the form that our equation will eventually take. And we can extract some useful information from this question. So first, the period tells us that 2 pi on n equals 4. And dividing both sides by 4 and multiplying both sides by n, we get n equals pi on 2. The range tells me that the minimum is 2 and the maximum is 6, which means the mean, sorry, that should be negative 2, not positive 2, so I'll just change that. The mean is halfway between negative 2 and positive 6, which is positive 2, and the amplitude is half the difference between the maximum and the minimum. 6 minus negative 2 is positive 8, and half of positive 8 is positive 4. You can also think of the amplitude as the difference between the maximum and the mean, or the mean and the minimum. This last part, the coordinate, will define the shift in the horizontal direction. So, putting all these things together, we have y equals 4 times sine of pi on 2 times, in brackets, x minus b plus 2. So we've already made a lot of progress. We just need to figure out what this value of b is. And to do that, we will use this last part here, where we've got a coordinate 0, 4. So we'll substitute x equals 0 and y equals 4 into this equation, giving us the following. Subtracting 2 from both sides, we get this, and we'll simplify this. Now we divide both sides by 4. And one thing you should remember is that sine is an odd function. If I take the sine of the negative of an angle, the result becomes negated as well. So I can rewrite this as negative sine of pi on 2b. Now the angle is positive. Multiplying both sides by negative 1. We get this. And now we need to recall exact values. So sine is negative in the third and fourth quadrant. So the solutions I need to consider are pi minus pi on 6, and pi plus pi on 6 in the third quadrant, and 2 pi minus pi on 6 in the fourth quadrant. Okay, so we'll simplify that. And now we'll multiply both sides by 2 on pi. And that gives us 7 pi on 3 and 11 pi on 3. Oh, sorry, pi on 2 times b. And so I can actually, if I divide by pi, that goes away. That looks better. Okay, now there are other solutions as well. So technically, I should write this plus 2n pi plus 2n pi and then this is plus 4n where n is an integer. Okay, so in the end we will choose either 7 on 3 or 11 on 3. Sorry, 11 on 3 because I've multiplied by 2 on pi. So we'll choose between 7 on 3 and 11 on 3. It's not clear which one it is because we don't have a picture of the graph. So now we need to use this part here. Assume that the graph is increasing at x equals 0. So what's happening here? I think it's helpful to draw a picture. So we have the graph going between -2 and 6, and the graph passes through the points 0, 4. So I don't know exactly what this graph is going to look like, but it'll be something like this rather than this. We're not going to have the solid line because we're told that the graph is increasing when x equals 0. Now, when is a sine graph increasing? Let's think carefully like this. This is the original sine graph. The graph of sine is increasing for values between 0 and pi on 2 and 3 pi on 2 and 2 pi. So if my phase is between 0 and pi on 2 or between 3 pi on 2 and 2 pi, then the graph is increasing. So let's now take a look at what the phase is, or what the angle is when x equals 0. Here. Since I've defined my graph to have this form, when x equals 0, actually, hang on, I'll put that back. Here we go. So now I'll pose the question. When x equals 0, y is going to be pi on 2 times -b. So I will choose between either this or this. Okay, so now I want you to think about this carefully. If I choose b equals 7 on 3, what happens? If b equals 7 on 3, then y equals 4 times sine of 7 pi on 6. Where is that angle? That angle is in the third quadrant, which is here. So it can't be that one. However, if I choose b equals 11 on 3, then y equals 4 times sine of 11 pi on 6 plus 2n pi. And where is 11 pi on 6? It's in the fourth quadrant, between 3 pi on 2 and 2 pi. So that tells me it has to be the second solution. So now I'll get rid of all this and I'll write something for you. Okay, so what should we say? Y equals, I'll say b equals 11 on 3, since sine of x is increasing, not positive, but it's increasing in the third quadrant. Hence, we want to go for the angle 11 pi on 6. And therefore, our solution to this graph is going to be y equals 4 times sine of pi on 2 bracket x minus 11 on 3 close bracket plus 2. Now, that was a hard question. What made this question hard was this last line here. Assume that the graph is increasing at x equals 0. If I didn't include that last line, then you would have generated two possible solutions for b. One would have been 7 on 3 and the other would have been 11 on 3. But I wanted to draw your attention to this fact that just because I've given you a coordinate, it hasn't actually completely prescribed the graph, because it could be increasing or decreasing at that point. To define whether the graph is increasing or decreasing, what we needed to do was consider sine and cosine and consider the angle and the quadrant. Okay, if you've got questions about this, just shoot them to me by email. I think the next example will be a bit easier. So let's finish with this one. This looks pretty straightforward. It looks like a sine graph. But I've asked for a cosine function. And one of the reasons why I'm bringing this up is because I want you to recognize that sines and cosines are translations of each other. So there's a few ways to do this. One would be to find this point here. It's 3 pi on 2, 2, and then consider a translation. You could do that. So why don't we do that first? So the amplitude is 2, and the period is pi. So that means 2 pi on n is pi, n equals 2. So if my graph has the form y equals cosine of nx multiplied by a, then I get y equals 2 cosine of 2x but I need a translation as well. And by inspection, the cosine graph starts at the maximum value when x equals 0. So here, imagine you started at 0 and then you shifted it 3 pi on 2 units to the right. It's the same as 2 cosine of 2 bracket x minus 3 pi on 2, which is 2 cosine of 2x minus 3 pi. Yep, that looks okay. And by symmetry, I can actually rewrite this as 2x minus pi because if I add or subtract 2 pi to an angle, the angle hasn't changed. So I'm allowed to do that. Sorry, this should be 3 pi on 4. I was thinking that doesn't look right. This is pi on 2 here. So this is 3 pi on 4. Now it changes to 3 pi on 4. All right, that's better. 3 pi on 4. 3 pi on 2. Okay, that's better. Okay, apologies. Now, that's sort of the easy way to do this. Now, something that you should notice is that this graph also looks like a sine graph. Specifically, it looks like y equals negative 2 sine of 2x. And I'm wondering, can I match this graph to this graph? Well, we know that, I'll just write it in a different color. We know that sine of theta is the same as cosine of pi on 2 minus theta, and cosine theta is sine of pi on 2 minus theta. So let's see what happens. I can rewrite this as negative 2 cosine of pi on 2 minus theta, which is 2x. Now it doesn't look like I've made much progress because I've got a negative value here. But remember, cosine is what we call an even function. So if I negate the angle, the value of cosine doesn't change. So I can write this as negative 2x minus pi on 2 in brackets. Okay, and now we need to think about this again. It looks like I'm almost there. It's just that I've got a negative sign. So now what I want you to think about is this. If I have a cosine graph and I translate it by pi units, does that negate the graph? Well, here's cosine up here. If I translate it pi units, what's happened? Lo and behold, the graph has been negated. So that becomes negative cosine of x. And so now I can write this as cosine of 2x minus pi on 2 minus pi. And behold, that gives me cosine of 2x minus 3 pi on 2. Do you need to go about it that way? No. Obviously, it was easier to start with this form involving cosine, but I just wanted to show you that you can start with sine, do some manipulations, and get back to the cosine at the end as well. Okay? But in general, make your life as easy as possible. Okay, apologies for the small number of hiccups, but hopefully it's clear enough. And yeah, just send me some emails or messages on Teams if you need further assistance with this topic. You should find the textbook questions are pretty straightforward. All right, I'll see you in the next video.